All right, let's actually take it the next step and start creating some full binomial distributions here. So in a survey, US adults were asked to identify which social media platforms they use. The results are shown in the figure. 6 adults who have participated in the survey are randomly selected and asked whether they use social media platform Facebook. So I'm just going to make a note here that we're focusing on Facebook. We're going to construct a binomial probability distribution for the number of adults who respond yes. All right, let me read through again here. So it says, in a survey, US adults were asked to identify which social media platforms they used. The results are shown in the figure. 6 adults who participated in the survey are randomly selected and asked whether they use social media platform Facebook. So again, we're focusing on Facebook here. Construct a binomial distribution for the number of adults who responded yes. So a success in this case would be a yes answer, right? So that's how we're defining it in this particular problem. All right. All right, so the first thing I want to think about here is N. So my number of trials. Now, again, we're focusing on just 6 adults here. So my N is going to be 6. We're considering success to be a yes answer. So our probability that someone says yes, they use Facebook, because again, we're focusing on Facebook here, is 68%. So 0.68 in decimal form. Our probability of a failure then is 1 minus p, so 1 minus 0.68, so 0.32. And then we do want to construct a table for every possible x here, right? So I'm doing the whole thing. So think about your possible x values, right? You could have 0 people who said yes, 1, 2, 3, 4, 5, or 6. And again, when you're listing all your possible number of successes, I don't want you to think about what is likely to happen. You just want to list the possible answers, right? So even though the probability is quite high here for a yes answer, there's still a chance that all 6 people could have said no, right? So you don't want to put your own opinion in there or what you think is going to happen. You just want to list what are the possible outcomes. So if I choose 6 people, I could have 0 people who said yes, 1 person who says yes, they use Facebook, 2 people who say they use Facebook, 3, 4, 5, or 6. So any of those 7 outcomes can happen. All right, so my number for my outcomes here, x could be 0, 1, 2, 3, 4, 5, 6. Now I'm going to focus on technology here, but afterwards I'll take a minute and just do maybe one of them out by hand again, just so you can see it one more time. But again, I really encourage you to use technology because we don't want to waste too much time doing these long, lengthy formulas, particularly if you have to do it 7 times, right? So it's going to take a long time. So I'm going to use my calculator here to get the probabilities. I'm going to use that same binomial PDF tool. And here's a little trick for you. If you leave off the x at the end, it will compute the probabilities for every x automatically. So it'll do all 7 at once. You don't have to go do it one at a time and say, okay, 0, now 1, now 2, now 3, now 4. It'll do the whole thing for you in one shot. So again, here's our last example. So remember this last value here was the specific number of successes. So if I want to, I could plug in any number from 0 through 6 here, right, and see what I get. But I'm going to do something different. I'm still going to start the same way. I press second, vars. So I press second, and then vars here. And I want to go down to binomial PDF. Now, what you're going to enter when you do your binomial PDF is you're going to enter n first. So my number of trials is 6. And then you're going to enter your p. And my probability of success is 0.68. Now, if I leave off the x at the end, it will compute every single x value outcome probability for me. So I'm just going to hit enter. And then what you can do is just use your arrow key to slide through. So that you do have to have your table set up on your own though. So it's not going to tell you which the x's are, but they'll go in order. So this first value here is for x is 0. So let's see, your book uses about 3 decimal places. So we'll do the same. So 0.001. The next value is about 0.014 if I round. Then for the next one, 0.073. Okay, use my over key. 0.206. 0.328. And I'm just rounding to 3 decimal places here, which is pretty common for probabilities. Here, 0.279. And then finally, 0.09. And then again, that 8 is going to bump up to 9 here when I round. So there's my whole table in one shot. I don't have to do the formula over and over and over again. I can get all the answers. Again, if you don't like this, it's okay. So what you can do is you can always go back and do them individually. So if you're unsure about this, you have your 6 trials, you have your probability, and then you can go through one at a time. So press 0 for 0 successes, and I'll give you just the first answer. And then what I can do is do it again. So I can write my 6, my 0.68, and now I'll type in 1 for 1 success. And again, it'll give me my second answer. So if you want to do it one at a time, you can. But if you leave off the last piece, so if you don't tell it how many successes, it'll run the whole thing for you. But of course, you still need to know on your end what those values are. So set your table up first and then fill in the little probabilities. Now I'll do the formula one more time just so we can see one last example with it. So I'm going to do, why don't we do this one by hand? So I'll do P of 3 by hand here. Okay. So my formula there, it was n factorial over n minus x factorial times p to the x times q to the n minus x. Now, my n is 6. I know my p and my q, and for this particular example, I'm going to use x is 3 here, right? So n is 6. So x is 3. All right, p is 0.68, x is 3. Oops, q is 0.32. And then I have 6 minus 3 here. And I'm just going to keep simplifying, right? So it's a little bit of a pain, but we can do it. 6 minus 3 is going to give me 3. Six minus 3 is 3. And again, I'm just going to keep going. So I have 6 times 5 times 4 times 3 times 2 times 1. Here, 3 times 2 times 1. 3 times 2 times 1. So what's going to happen automatically is this group is going to cancel. I'm going to have some more canceling too. All right, so let's see. Well, here, my 3 and the 2 will cancel with my 6. So I'll have 20 over 1 left, so that I just have a 20 times 0.68 to the third times 0.32 squared. And this is a good time to take out your calculator here, right? So you still have some work you have to do, and you're going to get about 0.206. Just make sure when using a calculator that your calculator does this cubed, does this squared before it multiplies it all together. So if you need to break this down further, you can, but you should still get the same answer. So you're welcome to use this if you want to, but like I said, I think that calculator is really a nice tool here to help you get through this faster. You can do it in Excel as well. So if you want to check out Excel, I encourage you to do that. I'm not going to go through it here because I think the calculator is pretty quick, and you don't have a lot of data you have to enter into the calculator, unlike the previous example. So it's really nice to do on that calculator app. But there is a way to do it in Excel as well. So if you check out your book, they'll go through in this section how to use some different technologies. So feel free to check that out if you're interested. Now I am going to skip example 4 in your text. So that's the one that goes through different technologies. So I've done it already with the calculator twice, but if you want to see some other ways, like with Excel and stuff, feel free to check that out. All right, let's do another example. A survey found that 17% of US adults say that Google News is a major source of news for them. You randomly select 4 adults and ask them whether Google News is a major source of news for them. Find the probability that so multiple questions here. Find the probability that exactly 2 of them respond yes, at least 2 respond yes, and fewer than 2 respond yes. Okay, so again, yes is going to be our success here. So the yes refers to that they use Google News. Now, we should be checking for each of these that we do actually have binomial distributions here or binomial experiments. I'm kind of skipping that because it's part of the examples in the text. But if you read through, notice that we have a fixed number of trials. So we're selecting 4 adults. So our N is 4 here. We have independence here. So if you're randomly selecting adults, you should have independence, right? There should be no reason why one adult would affect another adult's answer. Again, because it's randomly selected. It's not that you're choosing people in the same household or friends or things like that. You're randomly selecting, so the chance of one affecting the other should not exist. It should be independent. So you don't have an issue there. So you have that same probability of 17% or 0.17 occurring over and over again. And we see we have those 2 options of either success or failure. So we do end up hitting all the requirements for the binomial distribution. All right, so my N is 4. My P here is going to be 0.17 because that's what I'm considering a success, that someone said, yes, they use Google News. My Q then is 1 minus P, so 1 minus 0.17. 0.83. Now, my X is going to depend on the question. So notice here that in this one, I want my X to be 2. In this one, I want my X to be at least 2. So I want my X to be 2, 3, or 4 successes, right? Because I can go up to 4. And then here, I want my number of successes to be fewer than 2. So either 0 or 1. So it looks like I'm using all my different X values here. So I'm going to just create the whole distribution using technology and see what happens. So before I do that, I'm going to set up my table. Now X is our number of successes, and I have up to 4. So I have 0 successes, 1, 2, 3, and 4. Don't forget 0 when you're talking about successes. So it is possible that you have 0 people who said they use Google News. So whatever your N is, you're going up to that value. But again, don't forget that you should be starting at 0 if you're doing the full table, right? If you're not doing the full table, then it's fine. But if you're doing the full table, then we're going to start at 0 here. And then I have my probability. All right, so I'm going to use my calculator again. So I'm going to hit second bars. I'm going down to binomial PDF. I have 4 for my number of trials and 0.17 for my number of successes. I'm not going to put in an X here because I want it to give me all my X's at once. And again, I'm just going to make sure you're set up first so that you can actually just record your data. And I hit enter. So my first value, let's see, we're rounding to, I think, 3 decimal places again here. Okay. All right, so I get about 0.47, and this will be 5, right? Because I see 474, but the next value is a 5, so it's going to bump this up. Then for my next one, I have 0.3888, so that's going to become 0.389. Then I have 0.119. I'm going to use my touch it and use my over arrow to keep going. 0.0163, so 0.016. And then for the last one, now this one looks kind of weird. It says 8.3521 E negative 4. So what that means, when you have a negative sign like that, it means to move the decimal to the left 4 spots. So I take this and go 1, 2, 3, 4. And I fill in with zeros. So this is about 0.001 if I'm rounding to 3 decimal places here. If you don't have a negative, you move the decimal point to the right. So your calculator will use this notation here. Sometimes I'll use a 10, but 10 or an E when you need to move the decimal place in either direction. So there's my probability distribution, and now I can go ahead and answer my questions. So my first question was, I want exactly 2 yeses. So I want 2 successes here. So the probability when X is 2 is right here. It's just about, so I've rounded all these, 0.119. Now for the second one, I want at least 2. So I'm counting, so the probability of at least 2 means that I can count the probability of 2 plus the probability of 3 plus the probability of 4. So this is actually an or idea because I could have 2 or 3 or 4. All of those would be considered good. So what I'm going to be adding up here is, let's see, 0.119, 0.016, and 0.001. And I'm just going to do it on my calculator. And I'm getting about 0.136. Now your textbook got about 0.137 here. So I think we can avoid that little bit of rounding error if we actually use more decimal places. So if you're in doubt or you think you're going to have a lot of problems to do, it doesn't hurt to use more decimal places here. And then you can always round later. So that's a good idea too, is when you're doing this, you can always throw a couple extra decimal places in and then round at the end. Is what you like to do. So I got 0.136. You broke up 0.137. And again, that just has to do with rounding. By using more decimal places here, I'll get more accurate answers. And then the last one, I'm looking at fewer than 2, responded yes. So probably fewer than 2. Well, again, you're fewer, so you're strictly less than. So you're looking at either 0 successes or 1 success. And again, because we're an or idea here, we're adding. So 0.475 plus 0.389. And again, I'm getting about 0.864. Now your book here had about 0.863. And again, it's just a rounding thing. So if you're in doubt or you're finding you're a little bit off in my math lab, use extra decimal places as you're doing your calculations and then round at the very end. So it doesn't hurt to have extra decimal places unless my math lab specifically says to enter them in a certain form, that's different. But as you're doing work and calculations, extra decimal places is always a good idea. But we're right there with the same thing that the book had. They did this by hand using the formula, so you could do that too. But again, it makes it much faster if we can just go through and use that technology. So I do encourage you to try it out to save you some time here.